NASA and ISRO just released the most detailed images of the sun ever, and what they found inside, no one expected. We're talking about lava raining down from the sky, cracks the size of continents, and magnetic storms powerful enough to knock out satellites. But here's the wild part. These new 2025 discoveries are forcing scientists to rethink everything we thought we knew about the sun itself. And what do these strange structures mean for Earth's future? Today, we're diving inside the sun like never before. Let's start out at the top with the corona, the sun's outermost atmospheric layer, seen in extreme ultraviolet or X-ray light, hundreds of thousands of kilometers above the surface. Coronal rain, yes, plasma rain. In the corona, hot plasma rises, cools slightly, then falls back along magnetic field lines. It looks like molten metal raining, but it's charged plasma moving under magnetic forces, not gravity alone. Solar flares and coronal mass ejections, CMEs. Explosive events where magnetic field lines break and reconnect, releasing massive amounts of energy and sending plasma into space. In 2025, Parker Solar Probe captured multi-eruption events merging together, something we've never seen before. Coronal holes and fast solar wind, dark patches in UV images where magnetic field lines open outwards, allowing solar wind to escape at high speed. The solar poles are important here. In 2025, scientists detected ultrafine torsional Alfvén waves in the corona. Twisting magnetic waves thought to help heat the corona to millions of degrees. The corona is vastly hotter than the sun's surface, by a factor of about 100 or more, and these processes may explain why. Next, we step inward into the transition region in Chromosphere. This is the layer between the said corona and the visible surface, Photosphere. It's only about 100 kilometers thick in the transition region, but spooky things happen there. Temperatures in the transition region jump from Wisher's 8,000 Kelvin to 500,000 Kelvin in just a few kilometers. In the Chromosphere, researchers have spotted spicules, jets of plasma launching up at speeds of 50 to 100 kilometers per second, reaching heights of tens of thousands of kilometers before falling back. In 2024/25, new models showed that neutral uncharged particles in the chromosphere play a key role in letting these jets escape the sun's magnetic field. This resolves a long-standing debate. This is the engine room of the sun's atmosphere, where the energy transfers and plasma dynamics build up the drama we see in the corona above. Now we finally reach the layer we see with our eyes, the photosphere. This is the sun's outer surface, though it's not solid. It's about 400 kilometers thick and around 5,500 degrees Celsius. Sunspots, darker, cooler regions where the magnetic field is strong and upwelling heat is blocked. Granules, cells of rising hot plasma approximately 1,000 kilometers across, lasting approximately 20 minutes. Think of them like bubbles in a boiling pot. In recent research, 2025, scientists watching the solar poles with Solar Orbiter found supergranulation, giant convective cells, migrating poleward at 10 to 20 meters per second, crucial to understanding the sun's magnetic cycle. Every magnetic field line, every flare, every eruption originates here in the surface flow and magnetic patterns of the photosphere. Most of us see the sun as a bright yellow orb in our sky, but that view hides a wild, dynamic engine of plasma and magnetic fields. Every flare, every eruption up there can ripple all the way to Earth, impacting satellites, power grids, even radio communications. In 2025, new observations from missions such as Parker Solar Probe, Solar Orbiter, and the Indian Aditya-L1 have given us unprecedented detail of the sun's behavior. For example, the sun's south pole was imaged for the first time mid-2025, offering clues about its magnetic cycle. So the big question, what exactly is happening on the sun? And why are scientists scrambling to understand it better than ever before? What ties it all together is magnetic power. The sun rotates faster at its equator than at its poles, twisting magnetic field lines until they snap, triggering flares and coronal mass ejections. In 2025, Solar Orbiter's poleward views showed both north and south polarity fields present at the South Pole, confirming the sun is near its solar maximum and a field flip is underway. A major breakthrough, solar flare ions were measured at over 60 million degrees Celsius, up to 6 to 7 times hotter than previously thought. This changes how we model flare physics and space weather predictions. And now we have AI, Surya, an IBM/NASA model trained on decades of solar imagery that improves flare forecasts by learning complex patterns. Every solar storm that hits Earth could disrupt GPS, satellites, airlines, power grids. Knowing when and how they happen matters. A massive plasma plume dubbed the Beast, over 13 times Earth's width, was observed in July 2025, complete with coronal rain streaming back. Solar Orbiter will tilt further, reaching approximately 33 degrees by 2029 for even better pole views. NASA's upcoming missions will focus on fine-scale magnetic waves and tracking eruptions from the sun's far side. So this isn't just cool to look at, it's also the next frontier in protecting life and technology on Earth. The kind of cracks mentioned? In high-resolution imagery of the Photosphere and Chromosphere, what looked like pixels turned out to be the boundaries of convection cells and granules. The sun raining plasma? That's the coronal rain phenomenon, charged blobs cooling and falling back along magnetic loops. These visuals aren't just pretty, they're clues into how the sun's engine works. Despite all this progress, many major questions remain. How exactly is the corona heated to millions of degrees? We have candidates, Alfvén waves, reconnection, but no definitive single answer. What truly happens at the solar poles, and how does that control the sun's global behavior? The upcoming Solar Polar Orbit Observatory, SPO mission, planned for later this decade, aims to answer this. How can we refine forecasting of space weather to protect Earth's technology? Missions like NASA's Punch, launched 2025, will connect corona to heliosphere-wide events. Imagine the sun's hidden activity as the weather of space. What we learn today becomes tomorrow's protection. So, to wrap up, we peeled back the sun's layers, corona to transition region, and chromosphere to photosphere. We saw how magnetic fields, plasma jets, granules, and huge eruptions tie together. We learned that in 2025, solar science is more alive than ever, with new telescopes, missions, and AI bringing light to previously unseen structures. The sun isn't calm, it's powerful, unpredictable, and essential to our future. And thanks to science, we're finally seeing it in a new light. So, the sun isn't just a giant ball of fire. It's a living, breathing engine, shaping life across the solar system. Every flare, every storm, every wave of plasma, it's a message from our star. And now, with NASA and ISRO watching closely, we're finally learning how to read it. If you found this as mind-blowing as I did, hit that like button, share it with your science friends, and subscribe for more deep dives into space, tech, and the unknown, right here on TopX Scroll. Until next time, stay curious, keep learning, and keep scrolling.